Okay, so remember we just figured out the product rule, and I really want to stress that you got to memorize this product rule. Let's do one more example here where we have to use another product rule. So our next example is going to be y equals, let's let it be x squared plus 1 times 2x cubed plus x. We can see it's the product of two functions again. We have our first function, f of x, and our second function, g of x. Now, just like we did before, you could take the derivative, you gotta write it off to the side. Once you get good enough, you can just do it all together in one step. So let me repeat our functions, our product rule, and then let's actually take the derivatives here. So I'm going to continue on with that notation and those colors. So f of x, so that's my favorite part. You can just copy it without thinking. Then we have to take the derivative of g of x. So remember, we got to do the product rule, the power rule. So it's 2 times 3 times x squared plus, and then we just bring down that exponent of 1, and we got x to the 0. So we just have that derivative as 1. Okay, then plus g of x. So we replace g of x with 2x cubed plus x. And then take the derivative of the first function. The derivative of x squared is 2x, and then the derivative of 1 is 0. Okay, now we're ready. We just have to expand this. So let's write it. Let's do some cleanup here. X squared plus 1. We got 6 times x squared plus 1 plus 2x cubed plus x times 2x. All right, now let's expand these two binomials. We got 6x to the 4th plus x squared plus 6x squared plus 1 plus 4x to the 4th plus 2x squared. I don't need a parentheses, I guess. Okay, now we're going to combine like terms. We see there's an x to the 4th and 4 of them over there, so we get 10 x to the 4th plus 1 plus 6 plus 2, so we get 9 of them. X squareds and then a plus 1. And there we go. Here's our derivative. Now, if you look back at originally, you see we have two binomials here, so you could expand them as well. So recall, we got y equals x squared plus 1, and so this is another way you could do it. So this is like option 2. Okay, now we could expand this, so we get 2x to the 5th plus x to the 3rd plus 2x cubed plus x. If we combine like terms here, we get 2x to the 5th plus 3x cubed plus x. And remember, we're trying to take its derivative. So dy dx equals the derivative. We got 2. We bring down the 5. We got x to the 4th power plus 3 times 3 x squared plus 1. Clean it up. We get 10 x to the 4th plus 9 x squared plus 1. And we see we get the same exact thing as we did before. So if you want to use the power rule, you can. If you want to expand it first and then take the derivative, you can as well. So either the product rule or expand first and then the power rule. Okay, so that was multiplying. We used the product rule for the derivative. And now let's move on to the quotient rule. So if we're dividing two functions. Okay, so our top function is going to be f of x. Our bottom function is going to be g of x. If we go to take that derivative, this is what the quotient is. You take the bottom function times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And there's the quotient rule. I would like you to memorize this as well. And don't worry, we're going to get used to it so much, it's just going to come naturally. So if you want to remember it, you could say the top times the derivative of the bottom minus the top Okay, we got to start over again. Sorry about that. Here we go. We got the bottom times the derivative of the top. Minus the top times the derivative of the bottom all over bottom squared. And some people like to memorize it as high, and then d low. So the derivative of the lower function minus it's the opposite way. I did the same exact mistake here. Okay. Low. And then the derivative of the high minus the high derivative of the bottom over bottom squared. So what they say is low d high minus high d low over the bottom squared. However you want to memorize it, go ahead and do that. Let's do an example real quick. Let's say h of x equals x squared plus 1 over x cubed plus x squared plus 2. Now we have our top function is f of x. Our bottom function is g of x. We can see that we got to use the quotient rule because we have a quotient. So first things first, we're going to actually write it out. So g of x times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. We can go off to the side again. We write f of x equals x squared plus 1. The derivative is 2x. We got our g of x is x cubed plus x squared plus 2. We take its derivative. We get 3x squared plus 2x. And now we can just substitute in. So we have g of x is x cubed plus x squared plus 2 times the derivative of f, which is 2x, minus the top, which was x squared plus 1, times the derivative of the bottom, which we discussed was 3x squared plus 2x, all over the bottom, so x cubed plus x squared plus 2 squared. Okay, now the nice part is you can always leave that bottom the way it is. So do not expand. Okay, we're going to start off here in the next video. We're not done. We're going to expand this, expand the top.